Hi students, welcome to our channel BTech Mathematics. Today in this video we are going to discuss a question from MAT 101 exam held today 29/7/2021 for computer science and other students, and tomorrow we have exam for mechanical and civil engineering students. So this question will be useful for you. Okay, let's move on to the question. The question is expand Fourier series of f of x equal to, expand into Fourier series, f of x equal to e raised to minus x, 0 less than x less than 2 pi. It's a simple question, and we have the formula for Fourier series. We can write it as Fourier series f of x is equal to a naught plus sigma n from 1 to infinity a n cos n pi x by l plus sigma n from 1 to infinity bn sine n pi x by l, where we can find the coefficients. A naught is equal to 1 by l integral 0 to 2l f of x dx, and an is 1 by l integral 0 to 2l f of x into cos n pi x by l dx, and bn equals 1 by l integral 0 to 2l f of x into sine n pi x by l. This is the general formula to find Fourier series of a given function. Okay, now if you write this thing, you will get at least a minimum of 2 marks out of the total 7 marks. So writing the formula of a Fourier series is important to answer this question. Okay, now we can find all the constants a naught, an and bn. For that, first of all we want to see what is l. L is, here it is b minus a by 2. Okay, isn't it? Therefore, here the limit intervals, upper limit and lower limit, we can take it as 2 pi minus 0 by 2. This is equal to pi. Therefore, our L is pi. So, we can find A naught is equal to 1 by pi integral 0 to 2L. Here 2L is 2 pi, isn't it? F of x is e raised to minus x dx. Okay. Now this is equal to 1 by pi integrating e raised to minus x, you will get e raised to minus x by minus 1 from 0 to 2 pi. We can apply its limits. 1 by pi e raised to minus 2 pi by minus 1 minus e raised to minus 0 by minus 1, isn't it? Now we can write this as, I will write here, a naught is equal to 1 by pi minus e raised to minus 2 pi plus e raised to 0. That is, e raised to 0 is 1. Therefore, we can write 1 minus e raised to minus 2 pi by pi. This is our a naught. Okay. Now we can find its an. An is 1 by pi integral 0 to 2 pi e raised to minus x into cos n pi x by l. Here l is pi dx. Now we can write this as 1 by pi integral 0 to 2 pi e raised to minus x cos, cancelling these 2 pi's, it will be nx dx. To calculate this, we have a formula, e raised to ax into cos bx. To calculate this integral, we have a formula. We can use that formula to find this integral. This is the formula to find the integral of e raised to ax into cos bx dx. It is equal to e raised to ax divided by a square plus b square. Here a square, a is the coefficient of e raised to ax, a is the coefficient of x and e raised to ax, and b is the coefficient of x in cos or sine. Okay, this is the formula to integrate this. Here our a is minus 1 and b is n. Now we can use this integral, this formula, 1 by pi e raised to minus x by a square minus 1 square, it is 1, plus b square is n square, into a cos bx. Here a is minus 1, therefore minus cos nx plus b sine bx, n sine nx. You can use this formula. We have to find its limit from 0 to 2 pi. Okay. Now, applying the upper limit, you will get 1 by pi e raised to minus 2 pi divided by 1 plus n square into minus cos n pi into 2 sorry n into 2 pi, therefore 2 n pi. Okay, 2 n pi plus n into sine 2 n pi. Okay, this is the upper limit minus, here 1 by pi is common, we can write e raised to 0 divided by 1 plus n square, because lower limit is 0, into minus cos 0 plus n sine 0. This is the lower limit. Okay, now we can have 1 by pi e raised to minus 2 pi by 1 plus n square into minus cos 2n pi. It is even n pi's, isn't it? Even n pi, for even n pi, the value of cos is always 1. Therefore, it is 1 plus n into sine n 2n pi. For all n pi's, even or odd, sine will be 0. Therefore, it will be 0 minus e raised to 0 is 1, isn't it? For e raised to 0 by 1 plus n square into minus cos 0 is 1 plus n sine 0 is again n into 0, 0. Okay, now this is equal to 1 by pi e raised to minus 2 pi divided by 1 plus n square into minus 1. Here it becomes plus 1 by 1 plus n square. 1 by pi is common for all. Therefore, this is the answer. An is equal to 1 minus e raised to minus 2 pi divided by pi into 1 plus n square will be our an, isn't it? Now we will find what is bn is. Bn is equal to again 1 by pi integral 0 to 2 pi e raised to minus x into sine n pi x by l, here l is pi dx. Now we can write this as 1 by pi integral 0 to 2 pi e raised to minus x sine nx dx. To find this, we have a formula. We can use that. Okay, this is the formula. E raised to ax into sine bx dx is equal to e raised to ax by a square plus b square into a into sine bx minus b into cos bx. We can apply this here. Therefore, this is equal to bn is equal to 1 by pi e raised to minus x divided by 1 plus n square, isn't it? Because 1 a is minus 1, here it is a is minus 1 and b is n. Okay, now we'll apply this also, minus sine nx minus n cos nx. Okay, this will be the formula. We need to apply the limit 0 to 2 pi. Now we can calculate its upper limit as 1 by pi e raised to minus 2 pi divided by 1 plus n square into minus sine 2n pi minus n cos 2n pi. This is the upper limit minus, I will write the lower limit here, e raised to 0 by 1 plus n square into minus sine 0 minus n cos 0. This will be the limits. Okay, now we can simplify this. Bn is equal to 1 by pi e raised to minus 2 pi divided by 1 plus n square into minus sine 2n pi, it will be 0 because for all n pi's it will be 0, and for cos 2n pi the value will be minus 1. Sorry, plus 1, isn't it? Therefore, you'll get a minus 0 minus n here. Okay, then here also you can have e raised to 0 is 1, 1 by 1 plus n square into sine 0 is 0 and minus n into cos 0 is 1. Therefore, you'll get minus n over there. Okay, Now this is equal to 1 by pi. We can have a positive value n by 1 plus n square minus n e raised to minus 2 pi by 1 plus n square. This will be the value of dn. Okay, we can simply write this as n by or n into 1 minus e raised to minus 2 pi divided by pi into 1 plus n square. This is bn. Okay. Now we'll combine all these in f of x formula, Fourier series expansion. Therefore, we can have f of x equal to a naught plus sigma n from 1 to infinity a n cos n pi x by l. Here l is pi also, plus sigma n from 1 to infinity bn into sine n pi x by pi. Okay, now we will substitute a naught, an and bn. What is a naught? A naught is, here a naught is 1 minus e raised to minus 2 pi by pi. 1 minus e raised to minus 2 pi by pi. This is a naught plus sigma n from 1 to infinity an. What is an? An is 1 minus e raised to minus 2 pi by pi into 1 plus n square. 1 minus e raised to minus 2 pi by pi into 1 plus n square. This is an cos nx plus sigma n from 1 to infinity. What is bn? Bn is n into 1 minus e raised to minus 2 pi divided by pi into 1 plus n square into sine nx. Okay, you can have the answer like this. If you want to take the common factors outside, you can take 1 minus e raised to 2 pi by pi. That is a common factor for all these terms. So for 1 minus e raised to minus 2 pi by pi into 1 plus sigma n from 1 to infinity cos nx divided by 1 plus n square plus sigma n from 1 to infinity n into sine nx divided by 1 plus n square will be the Fourier expansion of e raised to minus x in the interval 0 to pi. I hope you understood what I said in this video. This is the important topic in Fourier series, to find the Fourier series expansion of a function. Okay, we will see in another video. Thank you. Thank you for watching.